Quadratic functions, vertex, standard, and intercept form. When we look at the parent graph of a quadratic function, y equals x squared, it makes a parabola, which is this U shape. It has vertex at the origin 0, 0, and then when x is equal to -1, y equals 1. When x equals -2, y equals 4. When x equals 1, y equals 1. And when x equals 2, y equals 4. We also have a new term called the axis of symmetry. And the axis of symmetry is a vertical line that passes through the vertex, and it also acts as a line of reflection for our parabola. Let's go ahead and use our parent function to fill in our chart to the right. The vertex of the parent function is 0, 0, the origin. The axis of symmetry is a vertical line that passes through the vertex, so it's x equals 0, the x-coordinate of our vertex. Because this is a parent function, there is no stretch or compression, and there is also no horizontal shift or a vertical shift. The x-intercept, we only have one at the origin, which is 0, 0. And our y-intercept is also at the origin, 0, 0. Now for the domain, our graph is going to go to the left and right towards negative and positive infinity. Our range, our lowest value is 0, and it's going to go upwards towards positive infinity. For our increasing and decreasing intervals, let's look at our graph. So we have negative infinity on the left side, positive infinity on the right, and our parabola turns at our axis of symmetry where x is equal to 0. So from negative infinity to 0, our parabola is decreasing. And then from 0 to positive infinity, our parabola is increasing. For end behavior, remember, we're just looking at what happens at the very ends of our graph. As x is approaching positive infinity to the right, our graph is going upwards to positive infinity. And as x approaches negative infinity, that means towards the left, f of x is approaching positive infinity as well. So this is all the information for our parent graph of y equals x squared. Next, we're going to take a look at 3 different forms of a quadratic function and what information in our chart we can get straight from the equation. The first form we're going to look at is vertex form, and that will read y equals a x minus h quantity squared plus k. Now from the vertex form, you can get the information for the vertex, the axis of symmetry, A, whether it opens up or down, and whether there's a stretch or compression, H, the horizontal shift, and K, the vertical shift. So when we take a look at this example of an equation in vertex form, I've highlighted the information that we can take immediately from the equation, as long as you remember what to look for. So the vertex is going to be our HK. Now remember, H, this one inside the parentheses with x is always opposite. So -5, 3. Our axis of symmetry is actually going to be the equation x equals and the x-coordinate of the vertex. So x equals -5. The compression or the stretch is based on our A. So we ignore the negative, and we're just going to look at the number 1/2. Because 1/2 is smaller than 1, we are going to have a compression by 1/2. Our horizontal shift is based on the number inside the parentheses following the x, and again it's opposite. Also, the x-coordinate of our vertex, which means we're going to go to the left 5 units. And our vertical shift is based on our k, which is also the y-coordinate of our vertex, and it means we're going up 3. Now this is all the information we can gather from a quadratic written in vertex form. Now the x-intercepts and y-intercepts, we can either calculate those by hand or on the calculator. And everything highlighted in yellow, we're going to need to use the graph to answer those questions. Now, we're not going to fill all that out now. We'll work on more practice in class, but we just wanted to focus on what information we can get from the vertex form. So now let's take a look at standard form. Standard form is in the equation y equals ax squared plus bx plus c. And straight from standard form, we can gather information about a, which tells us whether our parabola opens up or down, and whether we have a stretch or compression. The second thing we can get from our equation is the axis of symmetry. Now it's not quite as easy as vertex, but it's also not that complicated. The axis of symmetry is found from the equation x equals negative b over 2a, where b is our coefficient for x and a is our coefficient for x squared. And lastly, we can find our y-intercept, which is 0, c, our constant. So given this example of a quadratic written in standard form, let's go ahead and write in the information that we can find, which I have highlighted. So first, the axis of symmetry. We need to use the equation x is equal to negative b over 2a. Now, our b is a negative 1, and our a is equal to 3. So when you substitute in those values, we have x is equal to negative 1 over 2 times 3. So negative b means we have to take the opposite. So negative times negative 1, we have x is equal to positive 1 over 6. And you cannot reduce this. So our axis of symmetry is x equals 1 over 6. And when you look at a, the number 3, that tells us that we have a stretch by a factor of 3. Now lastly, we can take the y-intercept, which is going to be the coordinate point 0, and see our constant positive 2. So again, these are the 3 pieces of information we can gather from the standard form of a quadratic. Everything else will need a little bit more work to find the information, and then of course what's highlighted in yellow we'll answer after we have graphed the function. Now let's take a look at our last form of a quadratic, intercept form. And that looks like y equals a times the quantity x minus p times the quantity x minus q. Now p and q are inside of the parentheses following the x, just like our h in vertex form. So be mindful that we have a subtraction between x and p and x and q, which means whatever numbers we put in for p and q, we actually have to consider the opposite of that. So what information can we gather from intercept form? A, which tells us whether our parabola opens up or down and has a stretch or compression. And then second, we can also find the axis of symmetry. This time we have a different formula, x equals p plus q over 2. And remember, p and q are the numbers inside the parentheses after the x, but we have to take the opposite sign of what we see. Then we can actually find the x-intercepts from intercept form as well, hence the name. So our x-intercepts will be p comma 0 and q comma 0. So let's go ahead and take a look at this example written in intercept form and pull out the information that we can. So the axis of symmetry, we're going to use the equation x is equal to p plus q over 2. And we have p and q. It doesn't matter which one's which, really. You just have to remember that they are the opposite sign of what you see. So we have p is equal to negative 4 and q is equal to positive 1. So when we substitute those values in here, we have negative 4 plus 1, which is negative 3 over 2. So our axis of symmetry is the equation x equals -3/2. Now we can also look at A, which should come before the parentheses after the equal sign. And since we don't have anything there, that means we actually have no stretch or compression. The last piece of information we can get from the equation are the x-intercepts. So we're going to take P, which we said was -4, and make -4, 0 one of our intercepts, and Q, which was +1, and have 1, 0 as our other x-intercept. So this is all the information we can immediately gather from a quadratic function written in intercept form. Everything else, again, we'll have to do a little bit of work, whether it's by hand or calculator, to get the rest of the information. And everything in yellow, we will be able to answer after we have graphed the quadratic. That's it for this set of notes. I'll see you in class for more practice on the 3 forms, graphing, and filling in the rest of this chart.